In this lesson, we will look at Pyretic, which is an SDN language and runtime that implements some of the composition operators that we discussed in the last lesson. The language is a way of expressing these high-level policies, and the runtime provides the function of compiling these policies to the OpenFlow rules that eventually are installed on the switches. One key abstraction in Pyretic is the notion of located packets, the idea that we can apply a policy based on a packet and its location in the network, such as the switch at which that packet is located or the port on which that packet arrives. Pyretic offers several features. The first is the ability to take as input a packet and then return packets at different locations in the network. This effectively allows the implementation of network policy as a function that simply takes packets and returns other packets at different locations. The second feature of Pyretic is the notion of Boolean predicates. Unlike OpenFlow rules, which do not permit the expression of simple conjunctions such as and or negations like not, Pyretic allows the expression of policies in terms of these predicates. Pyretic also provides the notion of virtual packet header fields, which allows the programmer to refer to packet locations and also to tag packets so that specific functions can be applied at different portions of the program. Pyretic also provides composition operators, such as parallel and sequential composition, which we discussed in the last lesson. The notion of network policy as a function contrasts with the OpenFlow style of programming. In OpenFlow, policies are simply bit patterns. In other words, match statements for which matching packets are subject to a particular action. These types of policies can be particularly difficult to reason about. In contrast, in Pyretic, policies are functions that map packets to other packets. Some example functions in Pyretic include the identity function, which returns the original packet, none or drop, which returns the empty set, match, which returns the identity if the field f matches the value v and returns none or drop otherwise, mod, which returns the same packet with the field f set to v, forward, which is simply syntactic sugar on mod, to say that the output port field in the packet should be modified to the parameter specified, and flood, which returns one packet for each port on the network spanning tree. In OpenFlow, packets either match on a rule or they simply fall through to the next rule. So or, not, etc. can be tough to reason about. In contrast, Pyretic's match function outputs either the packet or nothing, depending on whether the predicate is satisfied. For example, we could apply a match statement that says match destination IP equals 10.0.0.3, and this function would take packets as input and only return packets that satisfy this particular predicate. In addition to the standard packet header fields, Pyretic offers the notion of virtual packet header fields, which is a unified way of representing packet metadata. In Pyretic, the packet is nothing more than a dictionary that maps a field name, such as the destination IP address, to a value. Now, these field names could correspond to fields in an actual packet header, but they can also be virtual. For example, we could provide a match statement based on a switch, indicating that we only want to return packets that are located at a particular switch, or on the input port, indicating that we only want to see packets whose attributes match a particular input port. The match function matches on this packet metadata, and the mod function can modify this metadata.